Morten doesn't want to wait any longer. Hello everybody, and welcome. My name is Aida Guerra, and I'm an associate professor in this Aalborg Center for Problem-Based Learning in Engineering, Science and Sustainability under the auspices of UNESCO. I've learned it by now. I have the great pleasure of bidding you all welcome to this important event that's going to happen here today, where our PhD fellow, Aida Guerra, is going to defend her PhD thesis, Problem-Based Learning and Sustainable Engineering Education, Challenges for the 21st Century. A special welcome to our members of our external members of the assessment committee, which is, and I'll start with the lady first, Associate Professor Magdalena Svanström from Chalmers Learning Center in Gothenburg, or neighboring country Sweden, and it is Associate Professor Jordi Segala Corral from Universitat Politécnica de Catalunya in Spain. So, heartily welcome to both of you, and of course also welcome to the chair of the committee, Professor Aida Guerra, who is from the same center, from the same department. The procedure is the standard procedure, which all of you, I'm sure by now, will be quite familiar with. It's a 45-minute defense by our presentation by Aida. After that, there's a 15-minute coffee break, which will be in a nearby room. Our secretary is busy setting up for the coffee break. And after the coffee break, there will be a 2-hour discussion where the assessment committee will ask questions to Aida, and Aida will give competent answers, I'm sure. And if any one of the audience who are present here would like to also be able to ask questions to Aida in the 2-hour session, then you're highly welcome to do so. But please do see me so that I can take down your name and can invite you for the speaker. So that is about it. After the 2-hour session, of course, the assessment committee will evaluate and see what verdict they come up with. We will all keep our fingers crossed for a positive verdict. And there will be a reception after the session. Aida, are you ready to go?
Yes. Thank you. Good afternoon, everybody, and welcome to my PhD defense. My thesis title is Problem-Based Learning and Sustainable Engineering Education Challenge for 21st Century. Engineering education is facing challenges to address challenges posed by society and industry. In one hand, they have to respond to the rapid knowledge production and technology breakthrough, and on the other hand, they have to address sustainability crisis. Not moving further in this introduction, these challenges call for new and innovative teaching and learning approaches in higher education. And these challenges, now I have blank. The challenges posed to engineering education is they have to introduce, they have to develop innovative and teaching and learning approaches in order to develop skills, knowledge, and competencies to address such challenges. Examples is to develop awareness on social systems, social sciences, interdisciplinarity, critical thinking, solving skills, and so on. So, how engineering education systems are coping and address these challenges? So my motivation, and I'll move now for the motivation of my study. I'm looking into the integration of sustainable development in engineering education. And education for sustainable development claims, from a theoretical point of view, claims for a systemic change throughout all the institution. It means that it starts from a top level with the missions and the educational paradigm with the management, with the curriculum design and development, to the in-classroom teaching and learning approaches. So, and of course, this all have to be aligned with the sustainable development principles, because that's what we are educating for, engineers. However, when I looked for the research documented and reported in education for sustainable development, from now on I will start to address ESD. Namely, in engineering education context, what I observed is a lack of focus on the learning process. The main report is actually focused on the greening and campus management initiatives. So how can university reduce their impact or have a sustainable impact in the overall society through energy savings from buildings and waste management and so on. So it's a very environmental management perspective. On the other hand, when it comes to teaching and learning, there's a lot of cases, and it's good, it's very positive. There's a lot of cases actually introducing strategies, how specific institutions actually address the integration of sustainability in their teaching and learning and curriculum development, for example, I mentioned. But there is a lack of focus. There are very few publications and research that focus on reporting what actually is the learning process taking place when the integration of sustainable development takes place. And this learning process, it's not only concerning the individual, but the collective. I remind that is from a vision and paradigm perspective through a management to a classroom practice. So what has been also highlighted in the by the theory, by the documentation of the research documented in the journals and conferences, is that problem-based learning, PBL, has been highlighted as a suitable framework, which means that provides conditions to develop the knowledge, the skills, and the competencies that engineers need to address the challenges. However, there is no such explicit explanation why PBL has. What are the learning principles of PBL that actually kind of meet the ESD theories and claims and principles and visions for education? So I started wondering about this, and that was actually I came to formulate my research question is, in which ways can PBL support the integration of sustainable development in engineering education? And I took the research approach from three perspectives. I look into the theoretic theories, PBL theories, and education for sustainable development, engineering education for sustainable development documentation as well. I looked from an expert perspective, and I looked from a practice perspective. And I must say this is it became an interesting approach when I was writing and preparing and everything, because it moves from the general to the contextual, to the abstract, to the concrete, from the theory to the practice. And also, each practice gives something that the others don't. For example, if I look only to the theory perspective, I will know what actually ESD is, what claim, what people should do, what skills and complexity students should be able to deal with complexity. But I don't know actually how they can do it. How can be the teaching and the learning design for it? So the practice would give me that perspective. Okay, but a practice and a context is very specific. Should that be general? Should that be extended to others? So I took the expert perspective to see actually what the experts, and when I say experts, I mean engineers. All of them actually were engineers and scientists as a background. They were involved in integrating ESD in their engineering institutions, education institutions. And they are from all over the world, and say, okay, this is what we did, this is our point of departure, this was the drivers, these were the challenges, this is the pedagogies, this is the strategies, but it's not, I didn't see actually the process. It was already implemented. So some way the perspectives complement each other. And for each, I also made a research design. So from the theoretical perspective, I made a comprehensive literature review where I look into theory of education for sustainable development, sustainability, engineering education for sustainable development, and from problem-based learning. And when I came to problem-based learning, I had to move a little bit for psychology and educational psychology, learning theories. But I was able to compare and find principles that are similar in both problem-based learning and education for sustainable development. The experts, my goal was actually to comprehend which strategies were carried out or being carried out around the world. What are the drivers for integration of sustainable development? The challenges. What are the role of the students? What are the role of the manager? So what is needed? What are the future perspectives as well? What is left to be done? And I select the experts from around the world and I interview them. And finally, and this is actually very dense, I went to see PBL practices and actually how they can support the integration of ESD. So I made a case study. And this case study, I made a selection of cases with some criteria. Of course, the institutions have to have problem-based learning and education for sustainable development because it's a requirement from the research question. I selected 2 programs and then I did documentary analysis, interviews, observations, and so on. So now what I focus my presentation is actually giving the main findings from these 3 perspectives, closing by answer to research question. So the theoretical perspective, I started by, as I mentioned before, doing a literature review regarding sustainable development, perspectives of sustainable development, and this is very, from a system perspective, from the institution as a whole, as an identity. So institutions can actually have several strategies or several approaches to integrate sustainable development. And this means that they start kind of awake for the challenges and the needs and the urgency to provide knowledge and skills on the area of sustainable development to engineers. So it could be an engineering education about sustainable development where actually courses and content about sustainable development are add-on the curriculum. So students have courses and acquire some knowledge, but that doesn't mean that they will change their practice. They will change their view of the importance of sustainable development and integrate their principles in how they actually became an engineer and practice engineer. So it doesn't change much in the educational paradigm. There's also engineering education for sustainable development, and in this sense, it includes more than just content. It has some value that management are aware. It's just not add-on courses, but sustainable development can be contextualized in the engineering profession. So what does it mean to be sustainable from an engineering perspective, for example? What engineers can do that address sustainable development principles. Sorry. So, and last, engineering education has sustainable development or sustainable education. And that's where it comes to title. I want engineers to have a sustainable education. That's my goal. And what actually happens is there is a transformative in the learning approach. It's from the missions that it's stated in the institution mission that we want to be a sustainable university. We want to educate our students, our engineers, scientists, lawyers, I don't know how many faculties can have, but anyways, engineering is the focus. Our engineers sustainable, under sustainability principles, have an awareness of that complexity, be able to work cross disciplines, address the needs of local society, and provide in a flexible and adaptable way what actually is suitable for that time. So, sustainable development, the perspective on sustainable development, become actually a transdisciplinary education. And transdisciplinarity, I mean that academicians, students start to collaborate with non-academicians and practitioners outside university. Systems thinking and holistic, it's complex. Students have to think more and collaborate and develop thinking across disciplines, understand the whole instead of just the part, what is concerned to them, the technical, for example. It's innovative, critical, contextual, participatory, and transformative. And this transformative is actually how students are able to change their values and their worldviews to a more sustainable paradigm. If the entire world changed to sustainable development thinking and become part of the way we see as a society, then what kind of transformation we will need next? So there is a character of flexibility in our culture and the ways we see the world. So when it comes to problem-based learning, I looked for the theory and I looked to the curriculum and the models. I focus only here in providing the 5 theoretical models of problem-based learning. And this is not context-specific. This is in terms, these models are characterized in terms of knowledge, in terms of problem scenario. Problem scenarios, there are real situations that students work with and analyze to formulate problems. Learning goals, role of students and staff, and assessment. In the Model 1, epistemological competence, the main learning goal is actually to develop, to know about a disciplinary content, about a discipline. So the problems are real but narrow and disciplinary oriented. Then we have Model 2, PBL for professional action, and this is actually the aim is to know procedural knowledge and also cognitive content, disciplinary knowledge in order to develop professional skills. Those are the learning goals. Model 3, interdisciplinarity understanding, and then here the problems start to acquire more complexity, become more open, more unstructured. And for interdisciplinarity understanding, there is the learning goal is to establish a relation between theory and practice. So students learn theories and then they go and practice, understand. It's become contextualized. PBL from transdisciplinarity learning and PBL for critical contestability. The learning goal here is students to become more contextualized. The technical context and the social, economical, environmental, the real elements of what is outside, they become blur. And for the critical contextability, it's actually, the learning goal is to develop a hybrid imagination. So it's a kind of mode 3 of knowledge production, which actually combines the technical and the social. So it's not technical oriented as a practitioner, it's not economic and entrepreneur orientation. It's become a social actor. When I compare these models with the ESD basic models, I could see actually a focus between the disciplinarity orientation to a more transdisciplinarity and interdisciplinarity and transdisciplinarity on the PBL models. Also, the problems become more open, more instruction, multidimensional from the first model to the last. Also, the critical thinking starts to have requires a different it's not just reflection, but towards what we are reflecting, what we are criticizing. So these models, the comparison, point me some variables and perspectives to what actually look into practice. And that means disciplinarity, knowledge, critical thinking, problem scenarios are some examples. From an expert's perspective, I carry out some interviews. I met the experts in conferences. I read articles from those experts. I must say, I learned a lot discussing and talking with them. When I found out that what I think is actually not an island, there's a lot of people thinking about more or less the same and having the same perspectives. So I select the experts, made a list of 27, contact 11, and interview 7. The interviews were structured, which means that I had already, I was not moving out of the list, the questions I want to ask about drivers, challenges, pedagogies, futures, perspectives, and roles, for example. And actually, another goal of the expert perspective is actually what is the role of PBL in these strategies. And that's the first finding I'm going to present you. The learning environment for education for sustainable development in engineering education, the characteristics they present, students should be active and the environment should empower students. Should be an interdisciplinary and a transdisciplinary education, should be transformative. This transformative word appears a lot along the discourse of the expert. Contextual, collaborative, participatory, and multi-criteria decision means that projects or the learning environment should involve students to make decisions in first place, but should not one direction with one criteria, but a multi-criteria and actually what the impacts of those decisions. When it comes to the learning strategies, problem-based learning and project organized, they become creative. They are the Boatwig. They are the living library. So their own institutions reinvent and adapt new strategies. But this is actually what comes to my attention, and why problem and why project? Because the learning is also contextualized. Students solve real problems. Students have become critical. So, okay, how can I investigate? I investigate through a case study, but how can actually PBL supports this integration? And then I came to a case study. Sorry. Just a brief of other findings of the experts. They also point me the different actors and roles. And it's actually, can we think about someone else to add to this list, including industry and social partners? It's really an integrative and holistic view. We have to bring external partners to the university and work together. And I call attention for these ESD champions, where I actually bottom teachers, students that have a natural interest in ESD. They are motivated to integrate this, and they are kind of alone until they start to have support from the above, from the top, and actually get more visibility. Also the resources. The resources, we have financial, but yeah, everything is almost about financial. But not only. We also have the human resources, the need to educate, to develop the staff for ESD. The educational resources, what to teach, how to teach. Cambridge University was one of the experts I interviewed, was from Cambridge University. They actually allocate some of the resources to develop the materials for the young teachers and so on. Challenges, the resistance to change, because our culture, our comfort zone, it's where we feel happy, basically. But sometimes we need to change, and this resistance to change is not the institution as a whole, but also students and academicians and so on. And also the culture of the discipline and so on. Future needs and perspectives. sustainability, literacy, resources, and more commitment. When I interview an expert, he called my attention to, we are finalizing the decade for education for sustainable development this year. And he said that not much has been done this. We are focusing on our institutions. Can we see the social system as a whole, the educational system as a whole? What actually is learned in elementary, high school, and so on, that when our students come to higher education, we don't need to give them the basics and of sustainable development. So there are interesting findings from the experts. When it comes to the practice, I made a selection of case studies. Which case? And initially, I wanted to do 10 case studies. And yeah, and now I understand why. So I did one, but I look into what is going on out in the world. So I didn't stay at home, as to say, but I look out. I compare what actually other institutions might have PBL and ESD. So I can always go back. No, now I go forward, but I can always go and compare, doing comparative case studies, because one is done. I think. So, I will present you now the main findings. I will not go through all, because there are quite a number of it, but I will give you those that I myself find them much more interesting. The first one is the challenge of interdisciplinary cooperation. And the interesting in this is it's because, my case study was Aalborg. I forgot to mention that, it's important. My case study was Aalborg, and I studied 2 programs, master programs. A master in civil engineer and a master in urban planning and management. Why these 2 programs? I look into other programs. I look into energy and technology. I look into media technology. I look into biology, if I'm not mistaken. I look into environmental management, but urban and civil, in my understanding, when I look into it, they have something complementary. Urban was more social oriented and civil engineer was more technical. So what actually are their practices in relation to PBL? And a lot of interviewees from urban development, UPM, they have background in civil engineering. So I went to the master. So there was interesting overlap here. So in Aalborg, problem-based learning is from 74, is part of the institutional identity, is part of the culture. So PBL, I can say, it's what we do, and that's how we should always teach. And I had interesting discussions. So if there's a need to change the PBL model or in learning approach, is that a challenge or not? So let's see. But here's the first challenge. The learning is team-based, but students and staff, they have a lot of difficulties to collaborate across groups, across programs. And that is the irony posed by this interviewee. He claimed that the curriculum is very structured, and it provides very strict guidelines of what students should deliver in their project, and that's what actually they are assessed. So I want to have good grades. I'm not going to another program and try to make cross collaboration, cross programs to if I jeopardize my grade. So another interesting finding in relation to interdisciplinarity is that students find it challenging to cope with diversity within the group, within the same program. Master programs are international, and when students that never experience problem-based learning come to this education, they have difficulties to cope with these new students. The educational background is different. The professional background and approach is also different. Some urban planners are more technical oriented, others are more social oriented, and they have difficulties. That's one of the challenges they pose. So, ASD claim for interdisciplinarity, but the practices I study, there are some challenges in both civil and urban. Reductionist versus holistic solving approach. Traditional engineer and science has a mechanist and a reductionist approach, which means that we pick a complex situation, a complex problem, and we broke it into simple parts. And then if we see the structure of these simple parts, when we understand the structure of these simple parts, then we extrapolate for the whole. But nowadays there is a change of paradigm. In our university, the problems are new, they are from industry, but the vision still is reductionist. So there is, from the civil engineer approach, there is a removal from the social and contextual elements. We mean where the problem is embedded, the reality, the problem scenario. However, there is an awareness that now things are changed, and calculate, everyone can do it. But not everyone can establish these connections between technical, environment, and economic aspects. I have very interesting stories coming from the interviews with civil engineers. And one of the stories was actually the impact of the reductionist approach. They want to make a remodelation in a building. It was a project to turn them more energy saving, zero energy building. So it was an old building, so how can, in the winter, we save energy? So what they did, they actually built an extension from the outdoor. So people will come out of the house, close the door, open the next door, and get out. So the heat will be remaining inside the house. What happened was that people perceived this extension as another compartment. So they put heaters there and use it as another compartment. And the words of the interview was, good intentions, disaster solutions. And then I asked, why didn't you ask the user, the people, what, in this scenario, what would they behave? Now we are starting to do it. So, and this was one story, there was another. So there is a need for a contextualization of the solution and see the human behavior and impact. When I came to the urban planning and when I was talking with the students, then it was something different going on. They had a more holistic view, but they are the ones going out and bring the problem scenarios to the education. So this student, particular student, she wanted to, she was in a, Aida is the engineering organization in Denmark, and she was in a presentation with an urban planner saying how urban planners do in real life. And she was hearing, and then she was questioning, is this the only way to do? There's something wrong. And then she picked the presentation and presented to the colleagues as a problem scenario. And this is one of the statements. Of course, she wanted to see the role of the urban planner, which forces, which impacts, who influences who in the decisions in the municipality. And of course, environmental is one factor, economic factors, policies, and so on. So they become more aware of the elements and the process influencing the profession in the social context. I have another story, but I have to. So another finding is PBL as a critical and transformative process. Critical thinking. People might think, yeah, but what is new there? Of course, PBL is argued to be one of the suitable because it actually develops critical thinking. Yes, it's true, but it's really hard to find in literature and research how this is done. What kind of critical and judgments and reflections students do. So I found 4 main perspectives. Epistemological, where actually students reflect and judge, develop criteria for the content. The holistic, the dialectic, but actually if it is a collaborative and a team-based learning, the reflection can actually be made in peer, with the partners, with the team members. And here, students have to develop an awareness that others have their own point of view. So there is a dialectic perspective. The holistic is that reasoning and critical thinking doesn't involve only cognitive factors, reflection, but also involves emotions and feelings. And the fourth and last perspective is related with transformative learning, which actually, through challenges, by being challenging and thinking, reflection, and questioning, students can actually be confronted that their worldviews and how they see the world might not be actually suitable in that situation. And then they actually might transform themselves. So, in this quote, we never do it just in a logical way. It means the solving process. Theories are never 100% accurate. You find this out when you do empirical work and you miss something. This miss something is what actually normally, a lot of times, drives researchers, which lacks and limits one's knowledge. And at the same time, students are very satisfied when they figure it out that by their project work, they discover and did something new. That what they see as being above them, the researchers with name and experience actually never realized or never came to the same conclusion. This is more linked with an epistemological perspective. Oops, sorry. In here, it's a quote from an interviewee from civil engineer, but actually it also falls in the epistemological that it becomes a problem when students lose their critical sense. Their ability to be critical, such as challenge different methodologies, understand how complex they are, or being able to familiarize themselves with a new topic. Civil engineers give a high importance of being the interviews, of being critical, and this is actually where the assessment falls. And this is a quote from the student. Your values will change afterwards. Many discussions are based on feelings and reasons why. This is a holistic and transformative. This is an awareness that students have that actually the academic staff and study board I interview never refer. And this was actually, I found interesting. Students experience problem-based learning in a very much different way than academic staff. Another example, I'm not really sure whether my values and beliefs change along the project, but it's changed along my education. So there is a reflection of looking back. What was my path? What I achieved? Other findings. There is a challenge to balance technical and societal context. If civil engineer is much more technical, focused on the professional development, urban planning, for example, is a more social oriented. Then it's much more focused on social aspects, but it loses the track of the professional object. Students are analyzing processes around what are the reasons, but they don't point to a solution. So they are kind of 8 and 18. Appropriate EST content and approach to the discipline. It's very difficult what actually the definition of EST. One of the students actually would be very nice to have a definition. This institution, this program have a definition of sustainability. So we can relate into and also relate the discipline. Break down prejudice and myths towards EST. The overcrowded curriculum. The overcrowded curriculum in our work is not in terms of content of the discipline subject that is delivered, but it's actually about the time students have to fulfill the requirements and complete the projects. And according to the academic staff, students that might not be so committed and motivated for EST, but it's something I would like to look into future, actually. Make use of existing structures and tools. There are some thinking, there are some knowledge within this in civil engineering, for example, about life cycle assessment, about eco-design, as we should not waste resources. There are some already embedded, some thought that could be pulled up and become more explicit. Yeah, so this is our other main findings. Now, moving to the last part, answer the research question. So, the research questions bring all together the theoretical, the experts and the practice, findings and interpretations and discussion, as problem-based learning can support interdisciplinarity, collaboration, interdisciplinary thinking, which can give the step for systems thinking. But the conditions, for example, mega projects, projects across programs, should be promoted. Students should become more autonomous, should be more independent, should be put as go out and choose your scenario, your multidisciplinarity, your multidimensional, unstructured, ill-structured problem. And then do a proper analysis with all these contextual elements. When they are confronted and they choose, they might actually give a step for transformative learning and all the perspectives on the critical thinking. Bring more contextual elements in the problem analysis and formulation. And this was something the students told me. If the sustainability, if the elements are not in the problem and that scenario, when we make the analysis to formulate the final problem, it not come throughout the process. So this also supports a more holistic problem-solving approach. And problem scenarios and solutions should include knowledge and the tools learned. If sustainable development is integrated in courses, suitable courses with themes that are linked with the disciplinarity. ESD learning outcomes. If ESD learning outcomes are considered throughout the curriculum, problem-based learning supports the learning and actually the assessment of these learning outcomes explicitly, and the learning principles, because some of the principles are already in place. Integrate and appropriate sustainable development concepts in lectures and projects, which means that the specificity and the concreteness of a project might be linked with the specific concepts of EST, with the themes. Some recommendations made by the interviewees from both experts, from practice. Students should be involved in all stages of integration of EST. They should give more voice. They should be called to participate more, to be more responsible in this process as well. Development, involvement, and commitment needed from the academic staff. There's a lot of interesting things regarding to this. Some might be kind of reluctant if someone defines you, asks you, say to you, if sustainability was a number, we could put it in an equation, and then it was integrated. Some are already very much involved, but there's a need to academic staff collaboration across departments, across programs, so they can actually become and see the need of EST. Make use of existing structures and practices. The problem approaches, the problem scenarios, the partnerships with external industry, for example, which is a lot of coming from outside to the university, and students work with those problems and those proposals. But there's not much, as far as I've seen in the project proposals and in the project, and when I talk there's not much of students going out and pick their own problem scenarios or giving proposals to industry, as far as I see. So I cannot generalize in this sense. This one is so difficult. Institutionalize PBL as well as ESD practices. And here is actually to make an assessment and auditing of the competencies and knowledge that students develop in the PBL process. As one interview from civil engineer pointed to me, we should not only rely actually on the industry good feedback, we should actually have our internal assessment tools. Institutions, and this is for a top level, have to show visible leadership. In the text, when they state missions, strategic plans, or in action, actually do something. One do can be actually supporting the bottom-up initiatives and allocate resources and recognition. Institutions who focus on employability not only develop skills for the profession as a demand from industry for the technological innovations and the breakthroughs, but also to develop responsible citizens. And it's it. So, thank you for your attention. I like this picture very much. I would like actually sometimes to have a travel time when I formulate a question to the results. But I probably would not have the same stories to tell of what I observe, of what I hear, what I have discussed, and further, even more, what I actually have learned through this process. The pain of being a researcher, I think it's a pain that transforms us. So I think I actually went through a process of transformative learning as well. So thank you very much for your attention.
Thank you very much, Aida. That was very precise and within time limits. And now I would like to invite you all to the nearby